Alright, let's do the last part of number 1, which is G. Alright, so rewriting this, we can do r squared plus 3i minus 1r minus 3i equals to 0. So this one, we can pretty easily factor this. This is 1, 1, probably positive 3i and negative 1. So this will be r plus 3i and r minus 1 equals to 0. So from here, we can get our answers. R can be negative 3i or positive 1. So we get to this case where we have one of our answers that's a real number and the other one is negative, it's an imaginary number. So in this case, we just use our most general option, which is number 1. So we can do phi of x equals to c1e negative 3i x plus c2 e to the power of 1x. And this completes number 1. Alright, so let's go on and consider problem number 2. Okay, so let me go ahead and solve this system first. So that would be r squared plus r minus 6 equals to 0. Factoring this gives us r plus 3, r minus 2 equals to 0, which then we have r equals to negative 3 or positive 2. So this gets us that phi of x equals to c1 e to the power of negative 3x plus c2 e to the power of positive 2x. So we're going to use this for all of our following parts A, B, and C. Alright, so let's go ahead and start with part A. Part A tells us to compute the solution of phi satisfying our boundary conditions. Okay, so let's plug in 0 for x. So phi of 0, this is c1 e to the power of 0 plus c2 e to the power of 0. So we know this is going to be c1 plus c2, and that value is given as 1. Okay, so this is our first equation that we found. So we're going to keep this here, set that aside. It seems like we have to now differentiate this. Okay, so I'm going to go ahead and do that here. That's going to give us negative 3 c1 e to the power of negative 3x plus 2 c2 e to the power of 2x. Alright, let me go ahead and plug in 0 in here. So that's going to give us negative 3 c1 e to the power of 0 plus 2 c2 e to the power of 0. So that's negative 3 c1 plus 2 c2. And that should equal to 0. Okay, so let me write what we have equals to 0. So we have two unknowns, so we can solve, and two equations. We can solve this. I'm going to multiply 3 to our first equation and add the system of equations. 3c1 minus 3c1, that cancels out. So we have 5c2 equals to 3. So from here, we have that c2 equals to 3 over 5. And probably from our original equation where c1 plus c2 equals to 1, we can easily find that c1 equals to 2 over 5 because these two numbers have to add up to 1. All right, then I think that's it. Our general equation, phi of x, is going to be 2 over 5 e to the power of negative 3x plus 3 over 5 e to the power of 2x. Okay, let's go ahead and to part B. Part B is very similar, but in this case, I guess we're considering psi of 0 instead of phi. So let me go ahead and plug in psi of 0. We're still using this equation, we're just considering it now. This is psi, not phi. Okay, so C1 times 1 plus C2 times 1, because we're plugging in 0 into our x's, that's going to equal to 0. So that's our first equation, C1 plus C2 equals to 0. We have to I'll write it down quickly again. The differentiated form was this, phi differentiated. Okay, so psi of differentiated psi of 0, that's going to equal to negative 3 C1 plus 2 C2, and that should equal to 1. So these are the two equations we have. I'm going to go ahead and multiply 3 again to our top equation. And I'm going to add these two equations, systems of equations. So positive 3 C1 minus 3 C1 cancels out. That was the whole point of multiplying 3 to the top equation. And we have 5 C2 equals to 1. So here we have C2 equals to 1 over 5. Probably from the first equation, we know that if C2 was 1 over 5, C1 probably is negative 1 over 5 because these two numbers have to add up to become 0. Okay, so then we have our psi of x equals to negative 1 over 5 e to the power of negative 3x plus positive 1 over 5 e to the power of positive 2x. Okay, I'm going to go back to our slide so that we can now compute part C. Part C, we just have to plug in 1s for both phi and psi of 1, psi equations. So phi of 1 is going to be 2 over 5 e to the power of negative 3. Oops, sorry about that. So let's go back here. Phi of 1 is going to be 2 over 5 e to the power of negative 3 plus 3 over 5 e to the power of 2. So this is our answer for E, well, the first part of E. And our second part is psi of 0 is going to be negative 1 over 5 e to the, sorry, it's asking to compute 1, so we're going to plug in 1. Negative 3 plus 1 over 5 e to the power of 2. All right, so these are the solutions for part E. Okay. All right, so now let's go ahead and go over number 3. All right, so for this given equation, I can start with r squared plus 1 equals to 0. So I imagine this is, we're going to have two imaginary cases. Let's solve. Subtract 1 from both sides, so we have r squared equals to negative 1. Square rooting both sides gives us plus and minus, so we have r equals to plus and minus I. I can go ahead and submit to our the first general equation, but I'm assuming it's asking us to plug it in to go back to randoms. Probably this one, especially this equation that I'm looking at, because it involves cosine and sine. And if I look at the part A, B, and C, which is it involves the pi over 2's, so probably I want to write my answer in terms of sine and cosine. Okay, so let's go ahead and do that. Phi of x equals 2 e to the power of alpha x. Alpha is beta I. Alpha is 0, so 0x. And it's going to be c1 cosine of beta x. Beta is 1, so it's just 1x, plus c2 sine of also beta x. So this reduces down to just simple c1 cosine x plus c2 sine x. All right. Okay, so let's go over starting part A. Guess we have to plug in 0 for x, so we have phi of 0. This becomes c1 cosine of 0 plus c2 sine of 0. Cosine of 0 is 1, sine of 0 is 0, so we have c1, and this should equal to 1. So we immediately find the value of c1. Let's plug in the next number, which is phi of pi over 2. This is going to be c1 cosine of pi over 2 plus c2 sine of pi over 2. This is going to be cosine of pi over 2 is going to be 0, plus c2 sine of pi over 2 is 1. So this is 2. So we get to these two solutions, which c1 is 1, c2 is 2. So by plugging in, we have phi of x equals 2 cosine x plus 2 sine x. So this is our equation for part A. Let's go ahead and do part B. Let me just rewrite our general solution that we have. c1 cosine of x plus c2 sine of x. Alright, so let me begin by plugging in 0. If you remember, sine of 0 is 0, and cosine of 0 is 1, so this is just c1. And c1 is given as 0 in our case. Let's plug in pi. So this we have c1 cosine of pi plus c2 sine of pi. Cosine of pi is -1, so we have -1 times c1, plus sine of pi is 0, so it's just 0. So we have that equals to 0. So we get that negative c1 equals to 0, which means c1 is at 0. So for both of our cases, we got that c1 is 0, but we don't have any information about c2, so we're going to have to just keep this. So our general equation, phi of x, is going to be c2 sine of x. But since this is our only constant, feel free to just get rid of that and keep this as our answer.